Okay. A company selling vegetable seeds in packets of 20 estimates the mean number of seeds that will actually grow is 18 with a standard deviation of 1.2. You buy 5 different seed packets. How many bad seeds do you expect to get?
10.
Why?
Because they have 20 seeds in the packet. I bought 5 packets and they estimate that 18 will grow, meaning that 2 won't.
Yep, 2 in every one they say won't grow. There's 5 packets, so 10 bad seeds.
No, I wasn't guessing.
I know he wasn't guessing, but I was just like,
Did we track with what he said?
I do know, yes.
I mean, it makes a lot of sense.
All right, what is the standard deviation?
1.2 seeds.
1.2 times 5.
For the bad seeds.
1.2
Times
seeds.
5. No.
2.4.
How about 1.2 squared, which is 1.44. So we're back to variance. Now we need to multiply that by 5, which is whatever, and then the square root of that number.
7.2, and then the square root of 7.2 is 2.68.
The 2.68 seeds would be the standard deviation for that.
Why do we square the standard deviation?
Because we have to do variance to be able to multiply. We can't multiply standard deviations. So we have to change it to variance, multiply it, then take the square root to get standard deviation again.
Right, okay.
What assumption did you make about the seed? Do you think that assumption is warranted?
I mean, like,
Most of them will grow
you're assuming that the seed will grow. 'Cause that's like,
Why?
because
it was planted.
they
and it
say
was
that 18 out of
watered.
20 will grow.
Okay, but
Most of them
does
will
the one seed growing affect another seed growing?
grow. No.
No. So what is that called?
Well, I mean, unless it takes all the
Independent.
Law
nutrients.
of averages.
Law of
That
large
doesn't
numbers.
exist.
No.
Law.
Not a law. Independence. Assuming the seeds are independent of each other. We could have a bad batch of seeds. Or we could have a really good batch. You never know. Like in one packet, you may have 10 that don't grow, but the other 10 do. But then the other one, all 20 grow. So it just depends. And it's safe to assume that they're independent without it actually saying that they are. I always used to wonder why my father-in-law was adamant that we plant multiple seeds in a hole at the farm. And I could never figure out what the purpose was. And he was like, that way if you have a bad seed, you still have a plant. Like, fair enough. Because then when they grow and they all 3 come up, because it was a good batch of seeds, then he's like, pull up 2 of them. And I'm like, you only keep 1 plant. Anyways. Real life application for you. For all the farming you're going to do in your life.
Actually, I'm gonna do some
But granted, in high school, I never thought I was going to farm. So, never know. One day you might.
I am gonna farm.
What are you going to farm? Oh, right. A no-kill farm.
As no kill as I can do.
Except for the bulls.
Why do the bulls have to?
But you can't
Did
have
you forget?
one.
Were you not here for that discussion?
He was.
What's
Oh.
that?
Because
You can't have more than one goal.
You can't have more than like 2, I think.
Don't they like hurt each other or something?
It's bad if you have more than one in a pin.
Yeah.
They get a little dominant, if you know what I mean.
Boys will be boys.
So true.
The average time to complete the Boston Marathon is 3 hours and 22 minutes with a standard deviation of 24 minutes. The average time to complete the London Marathon is 2 hours and 57 minutes with a standard deviation of 20 minutes. If someone competes both marathons, what time would you expect them to have?
A good one.
Like, what would their combined time for both be?
But add it together.
Like,
Hold on, 6 hours and 19 minutes.
I got 5 hours and 79 minutes.
Yeah, but I also got 5
Yeah,
hours and
let's-
79 minutes. But I
Let's
think
convert it
let's
over.
convert that.
6 hours and 19 minutes
yeah, I fixed it for you.
is the total time. Okay, because that's the average time for each one individually, so when we combine them, that would be the average expected time to complete both. What is the standard... Man, I'm like losing my voice. What is the standard deviation of the total time to complete both marathons?
Do you have to square
Can we
find the variance of the first?
So I'm going to do the first standard deviation squared. So that was 24 squared plus 20 squared. And then I'm going to take the square root of that number, so. You can go to like 1 or 2 decimal places either way.
31.24.
And that's in minutes, so make sure we put the time on there. On average, how much faster can a person run the London Marathon than the Boston Marathon?
Can we just subtract the average?
So 3 hours and 22 minutes minus 2 hours, 57 minutes. Whoa, undo. Come back. So I'm going to have to take away an hour over here, you know, all that lovely carrying math. Not inches. What am I doing? Minutes. 82 minutes minus 57 minutes is... Huh?
You didn't
The kids,
25
Rylan walked out of the computer lab and just said, gang, gang.
No, it was funny because
I thought you said he said I'm
and-
gay, and I was like,
Oh.
what?
What's
I
funny
said
was
that.
she was asking like, "What's this? Why is this?" And y'all went, "Gang, gang."
I was so confused.
And I was like, "What?"
I was like, what is happening?
happening?
What is the standard deviation of this
Wait.
difference?
25 minutes.
Wait.
I think he's still in the past, so disregard
You
his
said gang,
answer.
gang, and I said 25
It's
minutes.
25 minutes.
I got
the difference.
65.
Oh yeah, you did something.
82 minus 57 is not 65.
Where did you get 82 from?
It's not that.
I took away an hour.
wrong. And you add 60.
So there's 2 hours
You just
canceled.
look at
Oh,
this.
no.
You just look at this.
Oh, I was
Yeah.
doing, like, normal numbers, carrying.
Wait.
Yeah, he was
What?
doing, he was
And
doing
we used
minutes, he was
non-normal?
doing like
Oh.
the normal
Oh.
Oh.
You were doing it correctly.
Interesting.
like,
Well, clearly
You're
not
saying gang,
Peyton.
I
gang.
understand.
I
what you
didn't
did.
say it, Nathan did.
Alright, what is the standard deviation of this difference?
You have to do the variance and then subtract the two,
I don't know.
or are we not able to subtract variance?
I feel like I said this in our
Can't
note.
add-
Yeah, I feel like you
You
can
can't add
standard
standard
deviation.
but you can add
deviation.
variance.
Yeah, you can't. Yeah.
What about
Gang,
subtracting?
gang, no,
Wait,
that's-
that's just
Stop.
We can't subtract.
Can't
You
But
can't
add or
subtract
variance.
standard deviation, but you can subtract
No.
variance.
Always add variance. Even when we are looking for the difference. So it's the square root of 24 squared plus 20 squared, which we already said was 31.24 minutes. So that does not change.
What did you say? Little. It actually said a little way.
We'll try to set up the first part of this one, but the second part we'll have to save. In the 4x100 medley relay, 4 swimmers swim 100 yards, each using a different stroke. College team preparing for the conference championship looks at the times their swimmers have posted and creates a model based on the following assumptions. The performances are independent. The times are the normal model. So the mean and standard deviations of the time in seconds are shown below. What are the mean and standard deviation for the relay team's total time for this event? So the mean is easy. We just add it all up. So it would be 50.72 plus 55.51 plus 49.43 plus 44.91. And that's going to end up giving you 200.57 seconds. Now, standard deviation, what am I going to need to do to find that?
Find variance first.
Yep, so I'm going to, just to save writing, I'm going to write it as the square root of, and I'm going to do each of these things squared plus each other. So 0.24 squared plus 0.22 squared plus 0.25 squared plus 0.21 squared. And that'll end up coming out to 0.46 seconds. Alright, so we'll talk about how to figure out part B tomorrow. And then we'll probably be able to finish up the examples tomorrow as well, because there's not a lot left. So